In this section, we're going to be talking about the role of examples and models in math. So in this class, we're going to be doing a lot of proofwriting. And one thing that I'm going to be emphasizing a lot in this class is that each and every one of your steps has to be explained and justified. Right? So why is that? Well, I am going to give you an example of why you need to be explaining every single step that you're doing as crystal clear as possible, because if even one of your steps is not justified, then it can lead to a wildly incorrect conclusion at the end. Right? So what sort of things could lead to you saying something which, like, you feel like it's true, but you're not really justifying it fully? Well, one thing that could kind of lead to that is like understanding one specific example that doesn't actually generalize. Like maybe you have like a model for some axiomatic system, and this model has one particular property, and you think that like this particular property would just like generalize to like all other models for this system, and so you just kind of claim that. So that's like a thing that like might happen a lot. So that's just like something to keep in mind that like actually happens like a lot more than you think when people are proving things, and you just kind of have to be like aware that this is a thing that like you should not do and that people are susceptible to doing, and just don't do it. Just try to be aware of it. So anyway, let's get into the video. I'm actually like pretty excited about this video because I think this is like a really fun topic here. Because what I'm gonna do in this video is I'm gonna prove to you that any obtuse angle is also a right angle. Right? So that sounds crazy. I'm saying that any angle ABC which is bigger than 90 degrees also has to be equal to 90 degrees. So I have big exclamation marks here because that should be raising a lot of eyebrows here. So what I'm going to do is I'm going to prove this to you, and you're going to be completely convinced by the end of the video that angles bigger than 90 degrees are actually equal to 90 degrees. And so you're just going to be completely convinced by this. Or maybe you're not. Maybe you're going to find the flaw in my logic, the flaw in my reasoning, and you're going to call me out on it, and you're going to know exactly what's going on here. So let's find out if you're able to figure out, if you're able to find the flaw in my reasoning. All right, so let's start with an obtuse angle, ABC. For the sake of the picture, I'm just going to draw it like this. So here's ABC, and I'm just going to draw this like that. So this is some obtuse angle right here. So ABC. And then what I'm going to do is I'm going to turn this into a right angle. I'm not actually like breaking any rules by doing what I'm about to do. What I want to do is I want to take this line segment from B to C, and I want to rotate that line segment so that it actually makes a right angle with the line AB. So let's draw a line from B running straight upwards like so. Okay. And so I'm doing this such that, so let's call this point D right here. So I'm doing this such that the line from B to C is equal to the line from B to D. All right, and now I'm going to complete a rectangle here. So I'm going to make a rectangle out of this. I'm going to duplicate these edges and make a rectangle here, and then call this point over here E. All right, so I made this rectangle to have its two side lengths equal to each other and also equal to the length of the line segment from B to C. Okay. So that's one thing that we will start off knowing, is that AE is equal to BD is equal to BC. These three things all equal. Okay. All right, next thing I'm going to do is I'm going to draw a line from E to C. Okay, so I'm going to do that. And so now, because ABC is an obtuse angle, well, all right, I'm getting ahead of myself. I'm going to draw a perpendicular bisector to the line EC and also to the line AB. So perpendicular bisector for the line AB would be, so if you don't know what perpendicular bisector means, it's just a perpendicular line that bisects the line segment from A to B into two equal pieces. Okay? So one thing that's true about perpendicular bisectors is that if you pick any point on the perpendicular bisector of a line segment, say A to B, and then draw an isosceles triangle out, draw a triangle out of it, like I've just done, you're always going to construct an isosceles triangle. And the reason for this is that, so if I call this point O right here, then, so I would get that, well, I'm going to call this point of intersection M right here. So AM is equal to BM, and then, of course, OM is equal to OM, and then angle AMO is equal to angle BMO, because they're both 90 degrees. So then by side angle side, I get that the triangles AMO and BMO are congruent. They're congruent triangles. And then so all of their side lengths and angles are equal. And therefore, the sides OA and OB have to be equal. So that tells me that this is an isosceles triangle because OA is equal to OB. So ABO is an isosceles triangle right here. Okay. All right, I'm going to get rid of all that, and I'm just going to keep that fact in mind that if I draw a perpendicular bisector and then get a triangle out of that perpendicular bisector, I'm always going to get an isosceles triangle out of it. It's going to be important in a second. All right, so I drew the perpendicular bisector to AB. I'm also going to draw one to EC. So EC is like a little bit wider than like AB is going to be. So if I were to like extend the perpendicular bisector to AB upwards, then the perpendicular bisector to EC would the like point of intersection with EC would be a little bit to the right of that line right there. Okay, and also it would have to intersect the line, the perpendicular bisector to AB somewhere along here. And the reason being is because, well, EC is not parallel to AB. So to say that it's not parallel, I'm just going to put like a tilde right here to negate that statement. So EC is not parallel to AB. Okay, so that would tell us that their perpendicular bisectors can not also be parallel. So if the perpendicular bisectors are not parallel, then they have to intersect. Okay. So the perpendicular bisectors intersect, and where do they intersect? They're going to intersect at some point, which I'm going to call O here. And this is where that isosceles triangle talk is going to come into play, because now I'm going to start drawing some isosceles triangles. So let's draw some lines from O to A and then O to B. And then I'll also draw a line from O to C and then O to E. All right, cool. So, so hopefully we're good so far on the construction. My picture is maybe not the best, but this is what we're working with. All right. What can I say from here? Maybe I'll do purple next. Okay. So I had some isosceles triangles there, right? So ABO, that was an isosceles triangle. And then OCE was also an isosceles triangle. So what can I say? I can say that these two lines here are equal, OA and OB. And then these two lines here are equal, OE and OC. So I get that OA is equal to OB, and then I get OE is equal to OC. And the last bit of information that I need is something that I actually talked about at the beginning, which was that AE is actually equal to CB. So I had this line right here is equal to this line right here. And why was that true? Just to remind you why that was true. Well, BC, I just rotated it to the left a little bit to get BD, and therefore, like, this line segment by construction had to be equal to this line segment BD. So like I could put like that's equal to that, and then because I constructed a rectangle out of it, then this side length should be equal to this side length. So then B to C is equal to A to E. I should do it the other way around. B to C is equal to A to E. Okay, so I get that those three side lengths are all equal. And then by the side theorem for triangles, I get two congruent triangles. I get that OAE is congruent to the triangle OBC. So these are congruent triangles. So all of their sides and angles are all equal. Okay. So far so good. I haven't come up with any obnoxious contradictions yet. And now this is the fun part. So, because we're about to conclude this theorem here. So because these are congruent triangles, in particular, I can say that angle OAE is equal to angle OBC, right? So angle OAE, I can actually split this into two smaller angles. So I can split it into angle, so I'm going to call this angle 1 right here. So this is angle 1 plus 90 degrees. Angle 1 is, to be more technically correct, this is equal to OAB, and then the 90 degrees was just BAE, and that was equal to 90 degrees just by construction. That was just a rectangle there. And then OBC, this was equal to, I'm going to do the same thing. I'll zoom in a little bit here. So that angle right there, which I'm going to call that angle 2. So this is equal to angle 2. And then angle 2 was just angle OBA plus angle ABC, right? So that was, I'll zoom in again. So that was this angle right here. This angle right there, which is actually bigger than 90 degrees, right? ABD was the 90 degree angle. ABD was 90 degrees, and then ABC was a little bit bigger. And in our triangle OBC, that's the angle that we're going to get there. So then right here I have ABC, okay? So I have OBA plus ABC. All right, cool. I'm gonna just erase this stuff. Okay, so now what? Well, we're almost done. The last thing here is that angle 1 is actually equal to angle 2. Why is angle 1 equal to angle 2? So I have some things like redrawn down here just for like clarity's sake. So angle 1 is equal to angle 2 because, so I'm just going to delete some stuff. Delete that, delete that. Yeah, I'm just going to delete some of this stuff right here. So angle 1 was equal to angle 2 because I had this, because this was an isosceles triangle, which we had talked about before. So angle 1 equals angle 2 since triangle ABO is isosceles. Okay. So if angle 1 is equal to angle 2, then this equation right here becomes angle 1 plus 90 degrees is equal to angle 1 plus angle ABC. And then I just subtract angle 1 from both sides, and I get that 90 degrees is equal to angle ABC. And therefore, angle ABC is a right angle. So now we're done. Now we have proved definitively that that our obtuse angle that we started with, our arbitrary obtuse angle, was equal to a right angle to start with. Okay. And so yeah, that's the proof. Any angle bigger than 90 degrees is actually equal to 90 degrees. So obviously this is false. And so you're probably, if you're anything like me, you're scratching your head wondering what went wrong in this proof. Maybe you have a good idea what went wrong. I want you all to think about it. Think about like what, where did I lie to you? What was the, was I like, were all of my steps correct? Was there just like something that I wasn't telling you somewhere along the way? Like what's wrong here? So I want you to think about it. Well, I'm not going to tell you the answer right now. I'm probably just going to wait until next week to tell you. So enjoy the suspense. I'll tell you some other time. But anyway, think about it. It's a fun problem to think about. So anyway, that's the video. Hope you liked it. And yeah.